Good morning, everyone. Thank you so much for joining. We have Morvarid right here. She's going to tell us all about real-time insights. We have Sammy as well. Unfortunately, Sammy is sick, so we'll have Eero also helping out. If you have any questions, please ask them in GoToWebinar. We'll come back to them at the end of the talk and try to answer your questions as good as possible. And if not, we'll reach out to you after the webinar to answer your questions. I'll now hand over to Morvarid. Please go ahead.
Thank you. Hi, everyone. Thank you so much for joining us today. My name is Morvarid Aprin, and I'm Solutions Engineer here at Aiven. So I'm going to present how we can use Aiven for Flink to gain business insights in real time. Okay, let's take a look at the topics that we will be covering today. We'll begin with a short introduction to streaming analytics and the challenges faced with maintaining these systems. And then I will introduce you to Flink and how it can solve many of these pain points. And with that, we'll go through a real-life use case we have from one of our customers here at Aiven, and we'll see how Aiven for Flink is leveraged in the gaming industry. And at the end, we will have our Q&A session. Hopefully that sounds good. So let's start. First of all, the concept of streaming analytics, or in other words, real-time analytics, has been around for a while. Some well-known examples are the financial institutions who execute complex algorithms in real time based on an ever-changing streams of data. It can be stock prices, news updates, payment transactions, and so forth. And these systems need to be able to react as each new event comes in, for which it could be tens or thousands of events per second. And as you can imagine, building a system like this is not very easy. And experience shows it can be even more difficult to manage and maintain. So for handling the streams of events, we need a modern type of architecture. It's so-called an event-driven architecture for data and applications. It's a design that is centered around the data that describes as events. Events means something that just happened, basically. So, however, there are some they're very popular, but at the same time, they have some typical challenges for such systems. And first of all, is the question about performance and scalability of such systems. How can you reliably scale your system as it comes under increased load? More importantly, how can it scale during a peak of flow of events? For example, when the market open or close, or days such as Black Friday for e-commerce systems. And then there's a question about the resiliency and recovery. If a component in your streaming stack fails, how do you recover the state? Also, how do you prevent reprocessing the same data and avoiding duplicate flow to your downstream systems? And then there are some really great technologies in this space, but often the solutions are customized to the customer, like tailor-made. And some of these technologies are also proprietary in nature, which leaves a very small talent pool to select from when it comes to maintaining the system. And speaking of maintenance, how would you keep your system secure with regular security patches or operating system updates when the applications have to and are required to process the data 24/7? So to address these challenges, let's first introduce Apache Flink and the Aiven platform. So what is Flink? This is the exact quotation from the official website for Apache Flink. Apache Flink is a framework and distributed processing engine for stateful computations over unbounded and bounded data streams. Flink has been designed to run in all common cluster environments and perform computations in memory speed and at any scale. So in short, Flink is a distributed data processing platform that can process the events at very high speed and with low latency. mentioning the two types of unbounded and bounded streams. So Flink can work with both. It can work with bounded stream, also known as batches of data. And these batches can be processed by ingesting all data before performing any computations. This is also known as batch processing traditionally. But where Flink really shines, even though it can do the batch processing too, is what we're talking about today, is how it can perform this streaming analytics. Or in other words, doing continuous computations on unbounded streams of data as they arrive into your system. So with this brief introduction to Flink, let's return to our original challenges and see how this can help us out. We talked about performance and scalability. By design, Flink is a distributed system and will use all resources made available to it in the cluster, giving near unlimited processing power. Adding on to this, Flink also delivers further on performance by storing its local state. Either it can be in the memory, in the RAM, or if the total size exceeds available in the memory, it will store it in an access-efficient format on the local disk. For resilience and recovery, Flink guarantees exactly once state consistency. What we mean is that each incoming event affects the final results exactly once. Even in case of a machine or software failure, there is no duplicate data and no data that goes unprocessed. So Flink guarantees this by periodically and asynchronously checkpointing the local state to a durable state. Flink is also provided on the Apache license. It integrates easily with very well-known technologies such as Apache Kafka or Postgres. And as we will see shortly, when using Flink on the Aiven platform with SQL statements, you can quickly build powerful streaming applications. So that covers 3 out of 4 challenges I raised earlier. So what about maintenance? This is where running Flink on a platform such as Aiven has a huge value. So first of all, what is all Aiven about? Companies are becoming software because of generating so large volumes of data, and managing the data is costly, and businesses struggle with reliability of the data. And we are aware that cloud is an enabler for that. And at Aiven, we are passionate about open source technologies. Our mission is to make these open source technologies that helps with the data systems easily accessible for users on top of cloud infrastructure that customer has chosen. So for that, we provide the leading open source database and data streaming open source technologies on our platform as a service. We provide most popular technologies such as Kafka, Postgres, and of course Flink as a fully managed service across all major cloud service providers like Google, AWS, and Microsoft Azure. Talking about production-ready services, high availability of service is very critical. And when it comes to availability of the system, we have an industry-leading uptime SLA of 99.99%. And this is due our offering that for our customers, we have zero downtime when it comes to operations like applying patches on operating systems, or we're gonna do major minor version upgrades, scaling your services up and down, or migrating it from one cloud to another cloud, from region to another region. All these operations can be done in zero downtime for our customers. So this makes any maintenance on our Flink service really easy, and because Aiven will take care of those operations of the service for you, and therefore you can only concentrate to building your next great applications and do not worry about how the service is operating. So speaking of which, let's look at some examples of what Flink can do, and then we get into our case study. So Aiven's managed Flink service is a perfect companion for Aiven Apache Kafka, giving you the ability to perform reliable and also scalable real-time stream processing on your data. And here you see a data pipeline end-to-end by Aiven services, from which you ingest data from data sources such as Postgres and Kafka, and do stream processing on top of it before sending them down the line to a consumer service. Services like for data stores, for monitoring, and for analytics. So on Aiven platform, we provide integrations in between these services. And what is very powerful here is that once you have your data in services like Kafka or Postgres, what you need in order to do processing on top of it in real time is to simply use the skill statements with Flink to build the streaming pipeline and process the data as it arrives. You can enrich the data and make it more valuable before further consumption or thinking it into a data store. You have the ability also to monitor the Flink service with existing logs and metrics integrations as well. And as you see on the right-hand side, that data that has been already processed by the Flink service, it can be further indexed, analyzed, and visualized by popular services like OpenSearch or and in Grafana. Flink is extremely useful for data analytics and also business teams to create very complex analytics pipelines this way, much easier and simpler, where otherwise it would require weeks or months of engineering efforts. Here are some very common use cases for Apache Flink. I will give some examples for each of these. So one very common use case is alerting. The concept here is quite simple. Say you have a stream of data on a Kafka topic that contains data such as the stock prices. So I want to have an alert or take some action when the price goes down 5% from yesterday's closing. So previously you would probably implement this logic, built it into your like a microservice, and then in which you will calculate this pricing and to be able to create that alert and take the state from like a lookup table in Postgres. But now with Flink, instead of doing this, you can like do this comparison and this logic of like price comparison. You can build it in as a like a basic SQL statement. This is an extremely powerful feature, the windowing of Flink, which allows you to aggregate over windows of time on the incoming stream of data. For example, here's an example of identifying taxi hotspots in the past 15 minutes. This is visualized using the OpenSearch dashboards. While the concept may seem very straightforward here, but implementing it could be quite difficult. So you need to ensure that you're maintaining this state across the cluster. And that can be a headache, but with Flink, that has been made easy. Data filtering. This is becoming increasingly more important today with organizations, especially when you deal with sensitive data like PII data, HIPAA, and GDPR regulations. With Flink, you can easily remove or mask the sensitive fields in your raw inbound stream, and that it does not so you can make sure it does not accidentally land in a downstream system which does not have that privilege or doesn't have any legal access to that data. And the other use case at high level would be aggregating across multiple topics. So running Flink on top of services like Kafka or Postgres, you can also aggregate data that comes from different topics. And this is a very great example here when you can aggregate two streams of data that comes from two different service systems in your, for example, retail industry, streams of orders and streams of shipments onto two different topics. You can aggregate these two, joins these two streams of events, make it more valuable to be consumed down the stream, by other applications. So in this way, for example, you will have an up-to-date view of your inventory data. So taking these use cases that we just discussed, if we stitch all of these concepts together, we're going to show how they have been used in a real-world scenario for one of our customers. As is shown here, it's a high-level architectural view of our data pipeline. So the goal of this pipeline here is that we have users that are laying bets on various games. So each game is given a particular weight. And as a customer lays a bet, we calculate the total amount weighted by the game value. And this results in a score per user, which can then used internally for targeting the user, for example, for promotions. These weights are static and stored in Postgres. And one really nice feature of Flink is that leverage the data changes, by capturing them with like a CDC connector. And if you, for example, decide to update the weights in this storage, Flink will recognize this change and pull in the latest value. So once this score is calculated, two things happens here. First, the data is placed on a different Kafka topic, the enriched bets. And this enriched data can now be utilized in other parts of the business. For example, this could be used to trigger an alert or event to suspend the user account if you're worrying that the fraudulent activity is happening. The other event that happens is that we do send this into another Flink job. This time, we aggregate the data using the windowing functionality that discussed earlier, and from there store this data in OpenSearch. So we use OpenSearch in this regard, as it gives us some nice options for aggregating this data even further, which we then display in Grafana. As an Aiven user, when you log in, you will see our Aiven Console looking like this. This is like a single pane of glass that gives you a view into all our current services in your project. For example, here you see that we have 5 services running in provisions: Kafka, Flink, Postgres, OpenSearch, and Grafana. And the integration between these services is also provided by Aiven. So here now is how, like, if you look at the Flink job, as I have mentioned before, if you're familiar with the SQL statement, then this should quite seem straightforward. So we are joining 2 data sets together and then inserting them into a table, which in this case is an output Kafka topic. And next, we take this output data and we are going to further aggregate it, this time through by using the bucket of the data into 30 seconds window based by the user. So this data then gets pushed into OpenSearch, but just like before, we're still using very simple insert statements to do so. And here is how setting this up would look like in the Aiven Console. We simply specify the tables or inputs and outputs with our SQL statement to create the job. And this exact step can be done via the REST API, the CLI, or also with Terraform provider. This is up to customers to choose. With Flink, you also get the Flink dashboard. This interface allows you to dig into more detail on your jobs, check out the logs, and even see the data used in the job to help you debug if the job that you have created is misbehaving. And finally, we built some time series and histogram graphs using the Grafana with the OpenSearch plugin. And this is just some examples of the possibilities out there. For example, you want to plot the bets per minute or user, or the total value per minute user, or total credits So this can give us invaluable insight to the business in real time. And for example, if you need to be able to suspend an account immediately if they spot some fraudulent action or suspicious actions happening, you can act in real time. Otherwise, there can be very severe financial consequences for the business, right? So you avoid those costs this way. And as a result, no reputational loss, right? This was an introduction to this service. If you have more questions, please do not hesitate to reach to us now or even later on. You can also get this use trial code to log into, register to Aiven and try the service yourself, actually. Thank you very much.
Thank you so much, Morvarid. Really well done. We actually do have one question, so Eero should be joining us as well. There he is. So we have the question if we have any recommendations for companies currently using Spark and are considering moving to Flink. Maybe Eero can help answer that question.
Thanks, Leonie. That's a good question. Yeah, greetings from my side as well. I'm not Sami, I'm Eero, just replacing Sami here today. And on the question on the Spark, yeah, I guess key difference between Spark and Flink is that Spark actually works in the context of like micro patches. Both of them have support, for example, for SQL and then some windowing capabilities. But in general, I think Flink is more useful for if you have like complex event processing or like native streaming use cases. Mainly because it can provide better performance and latency and scalability. Windowing support is definitely a little bit better and more flexible on Flink side. And maybe the state management is also something that is more convenient and developer friendly on the Flink side of things. If those are really important for your use case, that would be definitely a good set of reasons already move into using Flink instead of Spark.
Thank you. Anyone has any other questions, please ask them now. And if not, I want to thank everyone for attending. We will send you the recording afterwards. And you'll get an email from us as well. Thank you for attending. I hope to meet you in the next webinar as well. The next one will be at the end of September and will be around ClickHouse. So hopefully you'll be joining that one as well. And have a lovely day and rest of the week. Bye.